Block's Blueprint is a blockchain-powered BPMS that uses the blockchain as a component to run business processes. The platform aims at implementing the traditional business process management lifecycle, but with some additional steps that cater to the blockchain. The new lifecycle starts out as the same old one, with the first step being designing the process. This is the initial step, where process designers map out business objectives with the highest priority that this process will solve and help carry out into existence. The next step would be the modeling phase, where the modeler will be using the block's Blueprint's modeling interfaces to illustrate visually the process. What follows is where the new lifecycle starts to differ from the traditional one. Originally, the next step would be to execute the process, but in the block's Blueprint ecosystem, the next step should be to transform the process into smart contracts so that they are compatible with the blockchain. And if users want to maintain compliances to regulatory rules, they can do so through injecting the rules directly into the generated smart contracts. After this comes the step of the audit, where they can perform a security audit to ensure that their smart contracts are safe and adhere to smart contract best practices, all before ultimately deploying the smart contract onto the blockchain. And from here, the lifecycle goes back to its original flow, where the users get to execute, monitor, and optimize their business processes. For the sake of this demonstration, we will be using the block's Blueprint platform to illustrate an imaginary scenario where clients, with no technical background when it comes to the blockchain, can request access to a portal that lets them create ERC-20 tokens on demand. During this process, the clients submit a request, and upon their request being reviewed and approved by a customer service client, they can create and receive their tokens in a flash. When you first log into the platform, you are faced with a list of your current projects. And since this is the first time accessing the platform, there are no prior ones, and therefore a new one must be created. That can be done through simply providing the name, the description, and the collaborators you want to add to said project. Once done, click on Create for your project to be created and added to the list, which you can then navigate to through clicking the new added item in the list. Inside, you get to create assets that you can use during the execution of your business process. And if you remember correctly, to implement the process of creating ERC-20 tokens on demand, we will be needing a mechanism to collect reviews on the requests submitted by the clients. This is where the form comes in, one of the assets you can create as a modeler in order to collect data from the end users involved during the execution of the business process. To create a form, you simply have to provide the name and the description of said form. Once done, click on Next to navigate to the form modeling interface. In this interface, you get to select from a list of elements the type of fields that you want to inject inside the modeled form. There are two sets of elements. Input elements, which are the elements used to collect data during the execution, and styling elements, which are elements used to leave visual cues inside of the interface, such as headers and separators to section your form, and paragraphs in order to explain what each section is for. For each element, there is a set of properties that you can edit using the attribute editor. These attributes depend on the kind of element that is being edited. For example, a paragraph element, which is a styling element, has only one attribute, which is the content of the paragraph. When an important attribute is left empty, the user is shown an error message to fill it out. Inside this form, there are two sections. The first one is for collecting details on the employee that have provided the responses, such as their identifier, which if you want to cater more to the blockchain data type, you can flag this field as a blockchain address, meaning that the value that the client will supply will be an address instead of a typical random ID. As an example, for a non-technical client, this could be their wallet address, as well as their full name and their email, just for the sake of being specific. The second one is to collect data about the actual feedback, which consists of the response to the request and a field where employee get to specify the reasons why they refuse the request. Once completely modeled, you can save the form and even download it if you wish to. Once modeled, the users can go back to the project and start working on second type of assets needed in this implementation, the business process. A business process can be created in the same way as the form. Provide the name and the description and click on Next to be taken to the process modeling interface. The process modeling interface consists of three major components. The inner sidebar, which showcases all of the currently supported BPMN 2.0 artifacts. The outer sidebar, which can be used to access the artifacts by type. You will notice in here a section called Web 3.0, which is not a type of artifacts offered by BPMN 2.0 specification, but rather a classification offered by the platform itself. And that is because the goal of the Blocks Blueprint platform is to bridge the gap between blockchain and businesses through not only the use of blockchain as an active component, but also the extension of BPMN 2.0 specification to support the modeling of blockchain Web 3 items. Currently, the sole item that is being supported is the Create ERC20 token task, with more artifacts on their way. Back to the inner sidebar. For each item, you get the ability to favorite that artifact so that you can always have it on top and thus becoming easily accessible, as well as being able to read the documentation of that element, a feature that is currently still under construction. In order to add elements to your process, all you have to do is to click on the artifact in the inner sidebar and drag it to the third major component, which is the modeling playground. And once you are satisfied with the placement of the artifact, click once to drop it. We will start by modeling the two entities involved in this process, the client and the employee, both of which are modeled using the element lane within a pool that represents the organization. The process starts with a start event named Request the creation of ERC20 token, which will be triggered by the client, after which the employee will review such request and use the user task titled Provide Feedback to use the interface modeled earlier to provide a response. The request could be either accepted or rejected, and therefore we use the diverging exclusive gateway in order to model the branching of the progression of the process. If the request is refused, then the client is simply notified about the rejection and the process ends. Otherwise, if accepted, the client is free to create their ERC20 token whenever they feel like it. And upon creation, they receive their token as an end of the process. You might think that this is the end of the modeling phase. But actually, as you can see when you hover on the transform button in the action bar, you will get a tip letting you know that you still have some errors in your process, and that you need to make sure that your process is completely error-free in order to move to the next step. You can visualize these errors through clicking on the diagnostics bar, where there are three sections. Errors, which are things that will cause issues in the transformation of your process into smart contracts. Warnings, which won't cause issues, but might cause the different supported languages compilers to issue warnings during the compilation of your smart contract into bytecode, and once fixed, it makes your process/smart contract more efficient. And at last, hints, which are just some corrections that once implemented will optimize the readability of your process, and by consequences, your generated contracts as well. You only need to clear out the error section to be able to move to the next phase. Each error inside the diagnostics bar will provide you with the error ID, a summary of the error, the element that is the root of the issue, and a detailed description of the error. There are two errors, one informing you that there is no default sequence flow of the diverging exclusive gateway, and another one letting you know that a user task inside of your process has no form bound to it. In order to fix these issues, you can head directly to the element and click on the Properties option. For each artifact, there is a set of properties. There are ones that are common between all of them, such as the ID and the label. And then there are specific ones that change depending on the type and the functionality of the artifact. For the user task, you simply have to choose which form to associate with this process. You will be getting access to the forms that you have created within the same project as the process. Currently, the only one being the one we have modeled earlier. As for the diverging exclusive gateway, you will have to pick how the process will progress in the case where all of the requirements for other paths to be taken are not satisfied through selecting the default sequence flow. And you will have to also specify what the requirements for taking each path that is not the default path. Once done, you can now compile your process into a smart contract. You will first have to pick the targeted language. Currently, we provide support for Solidity only, with other languages on their way. For each language, there is a short description as well. You can also select other options. There is the multi-file option, which structures your output in a folder, versus the single file option, which outputs everything in one file. Once finished, click on Next to be directed to a tab where you get to connect to the BPSC compiler, as well as visualize the textual representation of your process and the assets used within that process, such as the forms. And when connected to the compiler server, click on Compile in order for the compilation to start. You get to visualize the logs of your compilation if there are any. When instructed that the transformation is done, click on Next to visualize your generated output. You can then download your contract and the associated logs as well, or navigate back to your project and visualize your contracts anytime you like. Now with the first 3 phases done, on to the next phase, which is the injection phase. In order to implement this phase, you need to navigate to the deployments in the sidebar first, where you get a list of all of your projects. And upon clicking on whichever one you desire, you get to examine all of the smart contracts generated within it. You can choose which smart contract you want to preview and inject rules into. In this case, we will inject 2 rules inside a function called start process. These 2 rules are the KYC, also known as the Know Your Customer rule, and another rule that enforces geo-restriction on the entities interacting with the function. You can then go back and visualize the rules selected, or you can choose to edit the data of these rules as much as you wish to. Once you push the rules inside the smart contract will have the Rules Injected badge to signal the completion of the phase. And now if you were to click on Preview again, you can visualize the difference in the smart contract prior and post the rule injection. The next step would be to perform the security audit, the result of which is getting to know if there are any issues with the generated smart contract. Once the audit is completed, you can move on to the next step, which is the deployment step. It starts out with selecting which blockchain network you want to deploy your smart contract to. In this case, we choose the ARC network. You can provide a list of user addresses for your KYC rules. And once your contract is prepared, you should be taken to the next step, which is providing the addresses of possible clients and employees that will be participating in the execution of this process. And once data is supplied, we can simply click on Deploy. The deployment might take some time, but as soon as the process of deploying to the blockchain is finished, you can visualize the address and the data of your smart contract on the Block Explorer.